Hey guys, hope you are doing great. Maxim here, and in today's video I'm gonna show you how to generate the whole human life cycle using coding, right? So we're gonna look at Synthea, which is a synthetic patient population simulator, and it produces realistic but not real patient data and associated health records in a variety of formats, right? So let's look at just one table that they're giving me as output, right? Here we can see the observations table, which includes date, patient encounter, category, code, and description, and all this other stuff, right? So here we, for example, can see some blood tests done, with values, and it all can get outputted in the FHIR format. You can also do it in CSV or a bunch of others, right? So let's also see the other stuff that they're giving out, right? So we can see here, for example, a care plans table that includes all the care plan data. We can also check, for example, payer transitions. So you can really generate every single possible stuff that you can imagine that is related to patient data, right? But now let's actually go into the paper and see how it all works. So you can get it very easily and download it. It's from Oxford. And let's see the approach. So they're taking the health incident statistics and so they're taking health incident statistics, clinical practices, and medical coding dictionaries, and they're outputting it in also a bunch of different stuff like care maps, patient profiles, and all the rest. And key standards are HL7, FHIR, and the rest. But you can also output it as CSV as you want. So let's check at their workflow. It's very interesting. They're taking clinical care maps and incidence and prevalence statistics, which they map into these disease models, which are basically state machines. I will show you how each disease model looks like a little bit later. Then it's all also interconnects with synthetic world population that they're using census data demographics for, and also configurations that you can define yourself, and of course the exports in FHIR and all the other stuff, right? So here they give an example of this disease model, but let's actually see the actual ones that I downloaded from their GitHub. So here it goes. It's a PNG document. Let's just open it bigger and let's go through it. So we start right here, and this is for different allergies, right? So here we have chances of peanut allergy, for example, and it maps into this if we are actually getting the peanut allergy. Then we have also tree nut, fish allergy, shellfish allergy, and also other stuff, right? And then it all maps with different probabilities and interconnects in this graph, which is represented in the disease model. This whole file is basically a visual representation of disease model, right? And then we are getting the allergy incidence terminal, right? But let's also see how it looks in code. So if we open here, for example, here I have the pregnancy disease model, right? So here we are naming the pregnancy, define the remarks, and here are our all states. So we first checking if the gender is actually female. If it's not female, then we airing out. And here is all the different stuff. Initially no children, or maybe it's not the first pregnancy, and there is a bunch of stuff that is defined. It's a very long JSON file that you can go and explore on your own and see how it does this. You can also define your own custom models. I'm not a doctor, so I don't have enough experience into doing this, but it's really interesting for me to see how they did it, right? But now let's actually see how to use it, right? So let's go back to our browser and let's get here. As you can see, I already have it downloaded, but you can do it very easily. You just git clone it, cd into it, and open it in your editor. You do also a Gradle build check test, and then you can run Synthea by running this simple command. But you can also define a bunch of custom stuff. So for example, you can define the population, you can define the reference, the gender, minimal age, maximum age, and all the other stuff. So let me show you how you can use it, right? So let's actually go. I will go into output. Output is the folder where it all gets sent to. So for example, here I have my CSV outputs. Let's just clean it and we run it from the very start, right? So here I also built a small custom Python script that I'm using for my own purposes for medical card. but I will show it to you a little bit later. Yeah, so let's run Syntea query to generate, let's say, 100 patients that are age from 18 to 45, and they're females that live in San Francisco, right? So let's go. We do run Syntea patient 100. We specify age like this, 18 to 45. We specify gender like this, female, and let's also put here, we put California, and we put also San Francisco. Perfect. And let's hit run. Now we are starting generating it. That's how you should see it if the process is successful. So let's wait a little bit, and we'll come back as soon as it's ready. Actually, while it's executing, I will show you some stuff. So let's go into source, main, resources. Here you can actually access the modules if you want to, but that's not what interests us. What interests us is the Syntea properties. So, and here you can define a lot of different stuff. For example, if you want a CSV output instead of fire, you can just search for CSV, and here you need to specify true. Let me just search where it is. False. Yeah, exporter CSV export. You need to specify here true. Per default, it's false, right? But you can also, for example, you want to generate patients, and you're interested in only pregnancy from the age of, let's say, 18 to 21. Yeah. So you can just define your custom pregnancy model, for example, or take the existing one. Let's imagine you created a custom pregnancy model that is called like pregnancy 18 to 21, right? And then you can say something like generate only module equals pregnancy 18 to 21, and that's how you call basically only this. And then also in your terminal you specify like the age group, and for example that it needs to be from California, San Francisco, or whatever you prefer, right? And here you can customize it as you wish. Yeah, so you not only can create your custom models here in this main resource models directory, but you can also specify a lot of different stuff in your properties that will also help you out. Yeah, so now we are done generating, so let's see what we got. Yeah, and let's just go right here. Let's close this, open for example observations, right? What interests me the most. Let's open observations.csv. Exactly, and we are getting a very, very long CSV format with all the possible data. And now let's just divide it per client, right? So per patient. What I will do, I will go and show you my custom Python script that I created just for this. This is actually exactly how I'm generating synthetic patient data for the medical card, because eventually I figured out and found Syntea while I was searching for solutions to generate synthetic patient data, because I didn't know where to get the blood test data from and didn't want to do it manually, right? So let's just run Python per patient .py, and perfect, yeah, process 105 patients. Okay, that sounds great. I will show you later like what it did, but here's basically the code. We're just specifying, because what I'm interested is blood test results, so I'm just mapping out leukocytes, erythrocytes, and those other stuff. I'm opening this CSV file, and as you can see, it has a lot of different data, which is not only blood test, but it has also body weight, it has also heart rate, it has also other stuff, yeah, pain severity, tobacco, that whatever, systolic blood, and yeah, we don't need this, right? So let's just go and see our patient blood test, and for example open, I don't know, let's open this one, yeah, and here we are getting the date, patient, and here are also all the analysis criteria that we specified, so leukocytes, erythrocytes, hemoglobin, hematocrit, and all the rest. We are getting it mapped out. Obviously, if I want some more data, I need to play a little bit with this. Here we took from 18 to 45, maybe we need to extend the life length to get more data. Also, I can just build a custom model where they're generating blood test results, for example, every 6 months, right? It's also very, very possible. I just need to get my hands dirty with this and play a little bit with Cloud or ChatGPT to help me generate this JSON model to do it. But if you want me to generate a custom model and show how it's done, show how you can also define these custom properties and all the stuff to make very, very specific use cases for your applications, then please tell me in the comments and I will definitely do it. And up until next time, guys, see you in around 3 to 4 days with next video. Bye.